So as part of this session, we will talk about linked list and its operations. In previous session, we spoke about all operations in C++, like accessing an element, inserting a node at the beginning and its time complexity, inserting node at end and its time complexity, inserting node at a specific position of linked list, and deleting node at beginning, deleting node at end, deleting node at specific position. These operations we spoke, and also we spoke about the time complexity of each operation. So similarly, we'll talk same thing using Golang now, how to solve these problems in Golang. Okay. So basically, what we will do here is we'll try to implement a solution in Golang. We need to improve package main. So basically what we will do, we'll try to create a node, type node basically, type node of type struct, okay, and type struct which will have two values, data and also next, okay, a pointer. So we are ready with the node. Now we will create a linked list struct actually. Linked list struct which will have just head of type node, pointer node, okay. So we will see the operations. We'll start from inserting element at beginning. Let us start with this operation. And as we discussed, this will take O of one time complexity, O of one only, because at the beginning, right? Okay. Let us see. We'll write func. We'll take list linked list and we'll insert at beginning, and it will take data of type integer. Okay. We'll create a new node that equal to node data, whatever data we received, and next node will be list.head. Okay. Now what we will do is list.head equal to new node. That's it. So this is actually just creating node and we are inserting at the top. That's it. Okay. And here we are actually next node we are moving with the list head actually. Right. This is the insertion. This will take off on time complexity. Similarly, what we will do is we'll try to see the second operation, inserting node at end of the linked list. Okay. Okay. Now what we will do is we'll take the func list linked list insert at end the data of type integer. So here actually again we will create a new node equal to address of node data of data. That's it. I think that other element no need to, that will be by default null. Now while inserting, if you see that list dot head equal to nil, then list dot head equal to new node. Sorry, new node whatever we created. Else we need to traverse, right? Current node equal to ups. Yes. List dot head dot list dot head. Now we need to traverse across the nodes. Not equal to nil. Then current equal to current dot next. Okay. Once you traverse that, and we need to insert current dot next equal to new node. Actually, we are trying to insert at end of the list, actually linked list. So this will take actually O of n time because we need to traverse here till entire linked list. Okay. Next, third operation is we need to insert a element in a specific position. Okay. This also will take worst case O of n time complexity. Let us try to write that function also here. Func star linked list. Now we need to do insert at position. Here it will take two values, data and position of type integer only. Okay, now what we will do is we'll try to create a new node. Okay, of data. Let us check that if we list dot head equal to nil, then list dot head equal to new node. Okay. Also, you check if position equal to 0, then it is very simple. You need to see no node dot next equal to list dot head and list dot head equal to new node. Okay. Else, in the other case, actually what we need to do is, so now what we need to do in other case, we need to traverse current equal to list dot head. Okay. For I equal to 0, I less than position, I plus place. Okay. If current dot next equal to nil, then just to print error message here. Position out of range. Okay. And then return here. Okay. Otherwise, we need to keep moving actually. Okay. So once you come out of this loop, that means you are at right position. Dot next equal to current next and current next equal to new node. Okay, that's it. That is about all three operations of insertion. Now let us talk about deleting from the beginning, and also its time complexity is of 1, right? Okay, func list delete at beginning. Okay, if list dot head equal to nil, just print linked list is empty. Okay, else current node equal to list dot head list dot head list dot head equal to current dot next, and current not next is equal to nil. Okay, so we're deleting from the beginning. Okay, okay, now what we will do is we'll talk about next operation, deleting from the there. Basically this will take, there is no loops, nothing, it will take just of one time complexity, deleting node from the end of the linked list. So what we will do here is we'll try to iterate now. Func list linked list delete at end. Okay, if list dot head equal to nil, fmt dot println linked list is empty. Okay, else if list dot head dot next equal to nil, then list dot head equal to nil, because only one element is there. Else we need to iterate current node equal to list dot head, and for current dot next is not equal to nil. Keep continue, keep iterating current equal to current dot next. So at the end what you need to do is current dot next equal to nil. Simple. Okay. Now the last operation, the position, right? Trying to delete a node from the specific position. Basically, this operation also will take O of n time complexity because we are iterating through the loop. Now we'll try to delete element in a specific position. Okay. Func list linked list Okay. Mm, delete at position. We will take position integer. Okay. So what we will do is if list dot head equal to nil, nothing to do here. We need to print linked list is empty. Okay. Else if position equal to 0, then what we need to do is current equal to list dot head and list dot head equal to current next equal to nil. Okay. If position is 0 that, then else we have to do all operations. You need to take care about current equal to list dot head and for I equal to 0, I less than position I plus plus. We need to travels here. That's why this will take O of n time complexity. Worst case. Next equal to nil. Then you can print position is out of range. Okay. And you no need to do nothing here. Return simply the position of the deletion you are not able to find here. That's why. Now you just keep moving current equal to current dot next. Okay. Once you came to the end actually, I mean that the position. So what you can do is the temp node equal to current next. Okay. Current dot next equal to temp dot next. Temp dot next equal to nil. So we are trying to delete at the position, given position. Okay. Now we'll see that additional operation like for display purpose. Display linked list. Okay. Func list star linked list display. Okay. List dot head equal to nil. Fmt dot println list is empty. Okay. Else current node equal to list dot head. Now you need to current is not equal to nil. Fmt dot printf percentage of d comma current data and next println. Okay, this is the display part and also we'll try to write the get operation accessing access of accessing element actually. This actually, as we discussed, this will also take work and time complexity. Let us talk about this. Here I will write here. Okay. Oops. Func linked list get position int. Okay. For a given position, actually, if position is less than 0, return -1. Okay. Now current equal to list dot head. Okay. For equal to 0, high less than position I plus plus. Okay. If CURR equal to nil, return -1, because that position we are not able to see. Else current equal to current dot next. Once we came out of this loop, that means we are in a right position. Now again check current equal to null. If this is a null, that means that position nothing has. Okay. Else return error dot data. That's all about all the operations. Let us check this one using main function, and we'll call this. Okay. Linked list. Okay. Let us do the insert operation. List dot insert at beginning 1, list dot beginning 2, beginning 3, and try to display it actually. Let us try to test till here. Okay, display. Okay, so we are printing in the beginning order, right? So 2, 3, 1, actually like that it is printing. Now let us try to insert at end. List dot insert at end for list dot insert at end 5. Now try to display. Let us see what it will print. Okay, if you observe that 4 and 5 is inserted at end. Okay, let us insert in the position also. Probably we can insert at position